Welcome again to Adventures in Automation. We've built a lab. We've got IP Fabric up and running. We've set our goals for our first automation task, looked at Postman and at Python for making API requests into IP Fabric for data. But now we need to see how we can reach out and touch those network devices to start making changes. I'm going to quickly show you some integration with Ansible that I've been working on with the wider IP Fabric customer and partner community to show just how we can use IP Fabric to help with the task of automating config changes. But first up, Ansible. What is it? How does it work? It was originally developed as an open source project to automate deployment of configuration to servers, but now comes in a couple of flavors. The original open source project goes on, but there's also Ansible Tower, which is a commercial GUI based product, fully maintained and supported by Red Hat. The premise is really simple. You take an inventory as a list of devices and some parameters that relate to them: groups, access methods, host names, credentials, IP addressing, and so on. You then take a playbook, a set of automated tasks with some branching and looping logic wrapped around them and documented in a YAML file. And then you very simply run that playbook against the inventory and record the results. Obviously, it's a whole load more complex than that. Part of its appeal is that it can be adapted to deliver intricate automation workflows. But for the sake of this video, we're going to keep it simple. Let's break this down then. An Ansible inventory can be in a YAML or JSON format file, and in its simplest form consists of a set of groups of host names. Every inventory has to have an all group with the host section listing out all the names of the devices in the inventory. You then create child groups in order to break up your playbook logic into different groups of activity depending on that grouping. In our case, note that we have iOS devices and iOS XR listed separately. You'll also see variables defining the global all group, which will apply to every device. And within the child groups, which limits their scope, these might be used to differentiate the actions on the groups defined in the playbook. You'll see the file here shown in YAML format. The same inventory could also be in a JSON format like this. The playbook is a YAML file and consists of an ordered list of plays. Each play has a set of tasks which are run against a group of hosts from the inventory. If you look at our sample playbook here, we have two plays. One to retrieve the OSPF router IDs of the iOS devices from the inventory, and another to do the same for iOS XR devices. In this case, as you can see, the tasks are simple and very similar, but the command line details are different across the platforms. Each play matches up with a group of hosts, then executes a command relevant for its platform and registers the output into a variable. The debug statement simply outputs the content of the variable to the screen. And so we run that by asking Ansible to use our inventory file and our playbook, and it outputs the success or otherwise of the process. Now, we've chosen a very simple show command here to illustrate that playbook concept, but there's nothing stopping us building a much more complex play to, for example, configure NTP servers. And so we'll revisit that later. But how does IP Fabric help us with this process? Well, for one thing, the platform will of course retrieve the network data for us, so we don't actually need to fetch this data using Ansible. However, when we come to write it back, we will definitely need to identify the hosts that require updating and the groupings for those hosts to assign plays in our playbooks. And so we can use the data in IP Fabric to build our inventory files for Ansible. This Python script will use some predefined basic functions to get data from IP Fabric and output a JSON format inventory file for Ansible, which can be filtered and grouped accordingly. Let's see it in action. I've some environment variables created which hold defaults for the output, such as usernames and passwords for the devices and how I want to filter the inventory, which groups I want to define for the playbooks, and so on. The script prints a JSON output very similar to our earlier example inventory, using the same devices in Site45 and grouping the devices by operating system. Note that the output isn't quite the same. Our script is used directly as input into the Ansible command, which takes our output as its inventory without having to break it out into a separate file. As a result, there are a couple of extra constructs and some subtle differences in the layout of the file. But as you can see, when we run the playbook, we get the same output as we did using that sample static inventory file. So there you have it. You can see how IP Fabric can be used to serve up an inventory for your automation scripts. And so all that remains is to put all the pieces together. Look out for that video soon. Please comment below, email me, or join our channel on the Network to Code Slack to continue the conversation. Until our next adventure in automation, take care and stay healthy.